Okay, welcome for another video about circles, and we will be dealing about theorems on angles formed by intersecting tangents of a circle. So this will be theorem number 1 about intersecting tangents of a circle. So the theorem states that if two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. So we have here a figure in which this and this line is called a tangent line. So the definition of a tangent line is a line in which intersect the circle at one point. So the difference of a tangent line and the secant line is that a tangent line intersect only at one point and a secant line intersect 2 points at the circle. So therefore, these two lines here are tangent lines since these two lines intersect at one point of the circle here. So how are we going to solve if we have two tangent lines that intersect outside of the circle? And what is its relationship towards the 2 point of intersection of the two tangents with respect to the angle form of the two tangent lines? So the formula there is that we're going to solve, if we're going to solve for the angle form of the two tangent lines, so that means that this angle here, so we're going to solve that one using the formula that the measure of angle P, this angle here, is equal to half the measurement of the difference of your arc K, S, M, and our arc K, M. So if we can see here that these two point of intersection here, these two tangent lines, will divide the circle into two, one of which is a major arc and the other one is a minor arc. So this is our major arc and this is also our minor arc. So if we're going to add the two major arcs, that sums up with 360 degrees. So how are we going to solve for the angle form of the two tangent lines? So first thing we're going to do is we're going to solve first the measurement of either of the two arcs. So I have here an example. So if the measure of our arc KM, so it is provided to us that arc KM, the smaller arc here, is equals to 168 degrees, and we're going to solve for our arc P, angle P. So with that given information, what we're going to do is we need to solve first for our KSM, since what is provided is our arc KM, which is 168. Okay? So the question there is, how are we going to solve for our arc KSM? Okay, solving for our arc KSM is, since a circle's degree is 360, what we're going to solve is we're going to subtract our 360 minus the given, which is 168. That would be the measurement of our arc KSM. Okay? So since 360 is the measurement of whole rotation of a circle, and what is provided for us given is 168, our arc KM, then in order for us to solve for our KSM, we subtract 360 by 168. So what is the answer? 360 minus 168, that is 192. Okay, so that is 192 degrees. So we're going to use now our information after we have solved for our KSM, which is 192, and the given, which is 168, to solve for us for our angle P by using the formula, this formula. Okay? So the measure of our angle P is equals to 1/2 the measurement of our arc KSM minus the measurement of our arc KM. So again, if we're going to subtract, what we're going to do is just subtract bigger and smaller, or bigger minus the smaller, in order for us to have a positive value and not negative value. So let's solve further. So this 1/2, our KSM is 192 minus 168, the given. So that is 1/2. 192 minus 168, that is equals to 24. And half of 24 is 12 degrees. So therefore, the measurement of our angle P is 12 degrees. So that is our theorem number 1 on intersecting tangents of a circle. Let us now go to theorem number 2. Okay, for our theorem number 2, angle formed by a tangent and a secant. So we have two kinds of line that intersect outside of the circle, a tangent and a secant line. So the definition there is, if a secant and a tangent intersect in the exterior of a circle, then measure of the angle formed, so this angle here, is 1/2 the positive difference of the measures of the intercepted arcs. So the intercepted arcs are this arc here, this one, and this one here. So these are the intercepted arcs of the secant and a tangent line that intersect outside of the circle. So I have here a given. If the measurement of our DEB, so this arc here is equals to 186 degrees, and the measurement of our arc DF, so this smaller arc here, arc DF, is 70. Find the measurement of the angle formed of the tangent and the secant line that intersect outside of the circle, and that is angle C. So we're going to use this formula. So since our two intercepted arcs information has been provided for us, use directly, substitute, and solve. So therefore, this becomes the measurement of our angle C is equals to 1/2 the measurement of our bigger arc, which is DEB, minus the measurement of our smaller arc, DF. So this becomes 1/2, and this is 186 minus 70. So 186 minus 70. So that is 1/2 of 116. So what is half of 116? So therefore, the measurement of our angle C is equals to 58 degrees. So that is our theorem number 2, and that is very easy. Okay, let us now go to the second type of the angle formed by a tangent and the secant. So if a tangent and the secant, this is different from the first example of a tangent and a secant line that intersect outside of the circle. Now, here the point of intersection of the tangent and the secant line is at the point of tangency. So this point here, this is our tangent line, and this is our secant line. The two lines meet at the point of tangency on the circle. So what is the relationship of the intercepted arc and its angle form of the secant and tangent line? So the measure of each angle formed is 1/2 the measure of its intercepted arc. So it means that if we have a secant and a tangent line that meets at the point of tangency, whatever the angle formed here, that is equal to 1/2 the intercepted arc. So it means that if we're going to solve for our angle MPN, our angle MPN is equals to 1/2 the measurement of our arc MP. So this angle here, the intercepted arc is arc MP. And on the other side, if we are going to solve for this angle here, its intercepted arc is MTP. So this angle here is the same of how we're going to solve is 1/2 to the measurement of the intercepted arc. So I hope that is clear. So in example, if our arc MP is 170, find the measurement of our angle MPN. So here, so by using this formula, so we can solve for our angle MPN. So the measurement of our angle MPN is equals to 1/2 the measurement of our arc MP, which is given. So therefore, this becomes 1/2 of 170 degrees. And what is 1/2 of 170? So therefore, our measurement of our arc MPN is equals to 85 degrees. So likewise, if this arc here is given, we can solve that one, this angle here, by still using the 1/2 the value of the intercepted arc. So that is the second type of theorem number 2 of intersecting tangent and secant lines outside the circle, and that one is its intersection, its point of intersection is at the point of tangency. Okay, so I want you to solve for this one for application. Look at that figure there. So if our arc MRS is equals to 190 degrees and the measurement of our arc MY is equals to 70, solve for this 4. Pause the video for 10 minutes and let us try to solve that one. Okay, so let us try to solve for number 1. What is the measurement of our angle TMS? TMS. So we have TMS. So in order for us to solve, the fastest way or the easier way is, since we have now given, let us try to put those information on our figure here. So our MRS is equals to 190 degrees and our MY is 70. And from there, we're going to solve what is very obvious to solve by using our formula or our information about theorems of circles. So since this is an intercepted arc of the angle formed by our tangent and our secant intersect at the point of tangency, we can say that this angle here is half of 190. Okay, are we clear? So we can solve for TMS, or angle TMS is half of 190. So therefore that is half of 190. Okay, that is 95 degrees. Do we have the same answer for number 1, TMS? So for arc SY, so our SY here, if this is 190 and this is 70, so we can solve this one. So that is 190 plus 70. So that is 260 minus 360. So therefore that is, get the absolute value of that one. So therefore this is 100 degrees. How about for arc MYS? Arc MYS. So we can solve for that one. So since, yes, this is 90, 190, so this is 360 minus 190. So therefore that is 170. Am I correct? 170 degrees. So this is 17. So yes, this is 2. Let's start this up again. So our MYS. So this is 360. So therefore we can just add 190 and 70. 190 plus 70. So this is still also 170. Yes, that is 170. Since this is 100 and this is 70, so therefore that is 170 degrees. How about for angle P? So our angle P is, we have this intercepted arc and this arc here. So get 190 plus 70 and half of this. So 1/2 of 190 plus 70 is 260. Half of this one is 130 degrees. So therefore, this is 130 degrees. Okay? So that is very easy. And if you have questions, you can send your queries to me by messenger and I can answer it if I have time. And so that's it. So that is the theorems on circles about intersecting tangent and secant lines, or intersecting tangents. So that ends our video. Thank you.